Hi everyone, welcome to lesson 12. This lesson will cover translating and evaluating expressions. So the translating part, what we'll be doing, as you can see on this slide, is we'll be translating from words in English to algebra. So what we have here is some key phrases or common phrases or words that you'll see. And I've kind of grouped them by operation, meaning adding, subtracting, multiplying, or dividing. We'll see some examples of some sentences or just some statements, and then how to translate them from words into algebra. So let's take a look. The first section here, I have some words or phrases that are often referring to adding or addition. So you have this phrase added to, more than, increased by, and the sum of, or just the word sum. And let's see an example of a statement that uses each of these phrases. So we're saying statement because most of these are not even complete sentences. All right, so the first one, 7 added to a number. I guess the first thing to point out is when you see this phrase, a number, we actually generally replace that phrase with a variable. So if you just see literally the words a number, we don't know what the number is, so we use a variable like x or n, or really any letter of the alphabet, but a lot of times it's going to be n. So 7 added to a number, you start with the number, which is x, and then you add 7 to it. So x plus 7 would be one way to translate from this statement written in English into algebra, x plus 7. Now, as we all know, different languages have different ways of using words. So you might notice sometimes the algebra doesn't seem to quite match the English just based on the order of our phrases. So that's something that might be a little bit confusing. Even with this very first one, you might wonder, wait, why is the 7 going after the x? Because the 7 came first in the statement. For addition, the order doesn't really matter, but it will matter for subtraction, as we'll see in a few minutes. So you could also write 7 plus x. That would also be okay. However, I will prefer, and it will be better if you see something like 7 added to a number or subtracted from a number, that you put that after the x. Okay, so try to get used to the x coming first. Let's do a couple more so we can get used to some of these phrases. 5 more than a number. Think about starting with the number x. And then 5 more than that means you're adding 5. So I'm starting with x and then I'm adding 5. So this would be x plus 5. Okay, and these are not equations. I'm not solving for x. I'm not really solving any type of problem. What I'm doing is just practicing translating or changing from these short little statements in English into really a statement or a phrase in algebra, otherwise known as an expression. All right, next one. A number increased by 3. So start with the number. Increased by 3, that means, again, that you're adding, in this case, adding 3. Okay, last one. The sum of a number, that's x, and 4. And the sum of those things means you're adding. So you put a plus sign in between. So the sum of a number and 4, we can write x plus 4. Okay, where this is all going to be leading eventually, more in our third unit, we will be solving longer word problems. And part of the skill required to do that is to read a sentence and be able to translate it into an equation to solve. So that's what we're working towards right now. All right, let's move on to subtraction. Here are some phrases that we might see. Subtracted from, less than, decreased by, or difference between. This is not a complete list, of course, but these are some common words or phrases that you might see. So let's translate these from English into algebra. 6 subtracted from a number. Okay, this one is a good one to start with. The order does matter. So it would not be the same thing if you wrote 6 and then minus and then x. That would not be the same thing. Okay, the answer would be different. All you have to do is put a number in for x to see that those two statements are not equal to each other. For example, if you do 1 minus 6, that's not the same thing as 6 minus 1. One of those answers is negative, one is positive. Okay, so just be careful with order here. This is a phrase that you'll see again. If a number is being subtracted from another number, whatever you're subtracting from, that starts first. Okay, so 6 subtracted from x, that means you're starting with x, and then the thing you're subtracting, which in this case is the 6, if you're subtracting 6, that comes next. So that takes some getting used to. Anybody who's ever learned a second language or tried to learn a second language probably knows that you cannot just do a word-for-word translation, right? That's not how it works. You have to know full sentences, you have to know grammar rules, and phrases change order all the time. So it's no different with English to algebra right now. Sometimes the order is not what you expect. Okay, let's move to the next one, which is kind of similar. 7 less than a number. 7 less than something means you're taking away 7 from something. So 7 less than really translates to minus 7. Okay, minus 7 from what? Well, 7 less than what? 7 less than a number. What you're starting with is a number, which is x. Okay, so here's another example where the order of your words in English does not match the order of your answer. If I were teaching this class in another language, we might be having a different conversation about the order of certain phrases. But right now we're working in English, and so we're kind of focusing on that. So here's another phrase to get used to. 7 less than means I'm taking 7 away from something. I'm subtracting 7 from something. So 7 less than a number would be that number minus 7, not 7 minus x. So that is not going to be correct. You have to start with the x and then subtract the 7. All right, next one, a number decreased by 5. This one, you do get to keep the same order. So decreased by 5, that means you're subtracting 5. So this one, you do get to just keep it, x minus 5. And then finally, we have this word difference. So if you're finding the difference between two things, that means you're subtracting them, and you do get to keep the order the same here. So the difference between a number and 9, you start with the number, which can be x, and then subtract the 9. Okay, so that's difference. So difference between a number and 9 would be x minus 9. All right, good. So let's see some phrases with multiplication and division. I actually find these not quite as complicated. Let's see. So here's some words or phrases that are related to multiplication. Of course, the word multiplied, multiplied by. Product, or the product of. Okay, that means multiplication. Twice, this is one that means just 2 times a number. So you're multiplying by 2. And then here's the word of. Okay, that word by itself doesn't mean multiplication, but if you have a number after it, what you're going to do is multiply by that number. Okay, so if you have a number after the word of, that implies that you're going to multiply by that number. Okay, so once again, let's do some translating. So the first statement, a number multiplied by 6. The algebra becomes 6x. Okay, so speaking of order, what we saw on the previous slide is we were okay to switch order with addition. That was fine, but not with subtraction. With multiplication, once again, changing the order is okay. So as you may remember, we learned about the commutative property. The commutative property applies for addition and multiplication. So for example, with multiplication, A times B is equal to B times A, right? Order can be switched with multiplication. So for this first statement, a number, x, multiplied times by 6, you could write x times 6. You could even write x6, but you're probably already used to just seeing a number before a variable when we're dealing with multiplication. So let's try to stick to that. If you're multiplying a variable like x times a number like 6, rather than writing x times 6, you can write 6x. Here's the next one. The product of 4 and a number. That one can be 4x. And again, if you have a number just written next to a variable, that does imply that multiplication is happening. Next one, twice a number. Twice just means you're multiplying something by 2. That's what the word twice means. So 2 times a number, that can be just 2x. And then the last one here, we have a percent. So we'll see this more in our third unit. We'll see some word problems with percent, but now is a good time to remember when you see a percent, make sure you're changing it to a decimal. So this next phrase is 20% of a number. 20%, what that literally means, percent means per 100. So 20 per 100. 20 divided by 100 is 0.20 or 0.20. So what you might remember at some point is when you have a percent, what you can do to change it to a decimal is take your decimal point and move it 2 places to the left. If that's how you learned it, the reason why we do that is because we're essentially dividing by 100. Okay, that percent symbol really just means you're dividing by 100. It's kind of out of 100. So 20% would be 20 out of 100. 20 divided by 100 is 0.20. Okay, 20% of a number would be 0.20 times x. And so therefore I can just write it as 0.20x. Or just 0.2x is fine. Don't really need that extra 0. But I'll leave it so you can see the 20 still there. So 20% of a number can become 0.20x. All right, so those were our multiplication examples. Then the last few are going to be division. So the phrases we have are divided by, the quotient of, and 1/2 of. All right, so those are some examples. 1/2 of, that would mean you're multiplying by 1/2. Quotient, we've seen that word before. That just means it's an answer to a division problem. What I want you to get used to now is seeing our division phrases or expressions written as fractions. Here's our first one, a number divided by 8. The number we can call x. You can literally write the division symbol, the dot with the line and then another dot underneath it, and then 8. But let's instead write our final answer as x over 8 as a fraction. So x in the numerator, then the fraction bar, and then 8 in the denominator. That's another way of writing a number divided by 8. We can write it as x divided by 8, or as a fraction, we can write x over 8. All right, next one. The quotient of a number and 6, that would be a number x divided by 6. And once again, we can write it as a fraction, x over 6. All right. Now for both of these fraction answers, we could write them in a different way. Instead of x over 6, we could actually write 1/6 and then write the x next to it. So instead of x over 6, we can write 1/6 x. Those are the same thing. Either is fine. Which brings us to our very last example here, which says 1/7 of a number. So 1/7, I can write that as a fraction, 1/7. All right, and then 1/7 of a number means times a number. So 1/7 of a number would be 1/7 times x. So look at this. Now I'm writing multiplication instead of division. We know that these operations kind of go hand in hand. So I could write 1/7 x as my answer, or I could actually write it in a different way and just write x over 7, or x divided by 7. Because if you're taking 1/7 of something, you're dividing it by 7. Okay, so my hope is that for these first 2 slides that are full of words and full of statements that we've translated, you can kind of come back to this. If you see a phrase that you're not sure what to do with, hopefully you can find a similar example in this list. So let's move on to some problems here. All right, so our directions in this next set of problems goes as follows. Express each statement as an algebraic expression. Use x for any unknown number. Okay, so we'll start to use some of the phrases we just learned, and we'll see some similarities. We might see some slightly different phrases as well. Here's number one. A number divided by 2. Okay, so our goal is to translate from words into an algebraic expression or algebra. A number divided by 2. So the number can be x divided by, I'm writing a division symbol, and then 2. Or as we just saw, we can also write that as a fraction, x over 2. Let's do that instead. A third way you could write this would be, you could write 1/2 x. That would also be fine. But I like the middle one here, a number divided by 2. Let's write that as x over 2. All right, let's move on to problem number 2. 5 more than 4 times some number. Okay, let's read that again. 5 more than 4 times some number. Let's focus on this later part of the statement, 4 times some number. 4 times some number, that can be just 4x. Okay, but if we read the full phrase, it's not just 4 times some number, it's 5 more than that, right? So it's 5 more than 4 times some number. So we're going to take that 4 times some number, that 4x, and then we will add 5 to it. So the full final answer can actually be 4x plus 5. Read it back one more time. 5 more than 4 times some number. So you'd start with 4 times some number, start with 4x, and then take 5 more than that, then you'd add 5. So 4x plus 5. You could also write it as 5 plus 4x. That would be okay because of the commutative property. But if it was 5 less than, then we would have to keep it in the original order that I just wrote. So for example, if it had been 5 less than 4 times some number, we'd have to write 4x minus 5. We could not switch the order. So the best answer will be 4x plus 5. If you see something more than or something less than, stick that number at the end of the phrase. So once again, 5 more than 4 times some number will become 4x plus 5. All right, problem number 3, 19 less than n. 19 less than n. Okay, the most common error here is for students to write 19 minus n, and that is not the correct answer. So let's find out why. 19 less than n. Okay, if you just replace n with a number here for a moment, let's say, I don't know, n is 20. We'll just pretend. If you want 19 less than 20, here's what you would do. Wouldn't you start with 20 and then subtract 19? What's 19 less than 20? Okay, 20 minus 19, oh, that's 1. If you did 19 minus 20, that would give you an incorrect answer. Okay, so my point in that little example there is you might be used to switching the order for a phrase like this without even thinking about it. But somehow when there's a variable involved, maybe it seems a little harder. So 19 less than n is actually going to be translated into n minus 19. So what is it less than? It's less than a number n. How much less? 19 less. So we're taking away 19. So our final answer here is n minus 19. So once again, problem number 3, 19 less than n can be translated into n minus 19. All right, I'm going to erase the example with the 20 just so I'm not confusing you too much there. All right, so again, 19 less than n, you would write n minus 19. Okay, so the 19 less than turns into subtraction of 19. Okay. Number 4, 6/7 of a number. 6/7, you can write that as a fraction. Of is times, and then a number can be x. So 6/7 x would be one way to write that answer. You could write 6/7 times x, write a little dot in between, but There's not really any need to do that. Definitely don't write 6/7 and then use the X symbol for times. Now we have actual X variables. That's really confusing. So just write 6/7 X. Yet another way to write this, you could write 6x over 7. If you kind of stick that X into the numerator, that would also be okay. But I think the best answer is the one we circled, which was the original one, 6/7 X. Just put it right next to it. Okay, next slide. So now we're on problem number 5. The sum of X and twice Y. Okay, sum, we should recognize that as plus or addition. So we're going to be adding something. What are we adding? We're adding X, so X plus something. And what else are we adding? Twice Y. Okay, twice means you're multiplying something by 2. So twice Y means we can write 2Y. So our complete phrase here, the sum of X and twice Y, we can write X plus 2Y. All right, problem number 6, 15 multiplied by M. We can just write 15M for that one. All right, number 7, B subtracted from C. What are we subtracting from? Start there. So if you're subtracting from C, C comes first, and then the thing you're subtracting comes next. So this is another one where we're switching the order. So if B is the thing being subtracted, then we should write minus B. So our full answer, B subtracted from C, what we would write is actually C minus B. That's a good one to kind of star and come back to. These subtraction ones are the ones I've noticed the most errors being made, usually due to switching the order. All right, problem number 8, 25% of some number. Okay, we talked about percent, so 25%, we'll change that to a decimal. That's 0.25, and you can do that by moving the decimal twice to the left, or you can just do it by dividing by 100. So 25 divided by 100 becomes 0.25. So 25% of some number, we would write 0.25x. Okay, don't forget the x. Sometimes with the percent questions, students just change it to a decimal and think they're done. You're not done, okay? So a percent is rarely just an answer by itself. A percent is almost meaningless without a number after it. So 25% of what? Of some number. So in this case, our number is just x. So 25% of some number, we can write 0.25x. All right, good. So that was a bunch of translating. That's kind of the very first part of lesson 12. And then the second part that we're about to see is evaluating expressions. You might actually find this easier because now you get to actually solve problems and work with numbers, not so much with words. It's usually the word lessons are a little more uncomfortable when you're in a math class. Okay, so evaluate the expressions. What we're going to do is replace variables with numbers and then simplify. So let's see what that looks like. Number 1, 12g. And then what's written right after that is 4, the word FOR, g equals -7. So I think if we were to put this in a complete sentence, it's evaluate the expression 12g, and you might write when g is -7 or for g is -7. Okay, so it's basically telling you what to plug in. It's a formula, basically. So 12g, that means 12 times g. Well, what is g? We were just told g is -7. So what I will do here is replace g with -7. So I'm writing 12 times -7. And then all we have to do is simplify. 12 times -7, that's -84. So finally, we get to have nice number answers. Maybe that feels better than what we were doing. Okay, so once again, number 1, 12g, for g equals -7. You replace the g with -7. Notice how I put it in parentheses. We're multiplying it, 12 times -7, and then we got our final answer, -84. All right, number 2, 2x over y, so it's a fraction. And this time our variables are x equals 25, and y equals -5. So let's rewrite the original problem, but I'm leaving some kind of empty parentheses where I can plug in my variables. So in the numerator, we had 2x. Let's replace that x with 25. And then in the denominator, we had y. Let's replace that with -5. So let's plug in. So our fraction is now 2 times 25 in the numerator over, and then the denominator is now -5. And now it becomes a little order of operations problem. So 2 times 25, let's simplify that. That's 50 in the numerator over, and then -5 in the denominator. So 50 over -5, I mean, this is just division. 50 divided by -5 is -10. So our final answer is -10. All right. Next is number 3. It's a fraction, 6 over a plus b. So a plus b is in the denominator. This time a is 19 and b is 11. So let's rewrite it, 6 over. Instead of a, we'll write 19 plus, instead of b, we'll write 11. So we're rewriting it as 6 over 19 plus 11. So now to simplify, we need to add the 19 plus 11, which is 30. So we have a fraction 6 over 30. Okay, you might think the answer is 5 here. Be careful. The answer is not 5, but we can reduce here by dividing both the numerator and denominator by 6. So you might be looking at this thinking, oh, 30 divided by 6 is 5. That is true. Let's divide both the numerator and denominator by 6. So my numerator, 6 divided by 6, that's 1. The denominator, 30 divided by 6, that's 5. So my final answer is 1 over 5, because 6 over 30 reduces to 1 over 5. Okay, number 4. This one's longer. M plus n, and then parentheses, 5 plus n squared, close parentheses. M is -11. N is 3. And there's 2 different places where we will be plugging in that number 3, because there's 2 different places where there is an n in the problem. Okay, so let's rewrite it. Here we go. So instead of m, let's write -11, then plus, instead of n, let's write 3. Then right next to the 3 is parentheses, which means we're going to be eventually multiplying. Inside the parentheses, there's 5 plus, instead of n squared, we're going to write 3 squared. And then close the parentheses. So the fully written out problem right now is -11 plus 3 parentheses, 5 plus 3 squared, close parentheses. Speaking of parentheses, let's start there. Order of operations. So inside our parentheses, we have 5 plus 3 squared. Okay, well, if we treat that like it's its own order of operation problem, 3 squared is 9, and then we'll do 5 plus 9, which is 14. So let's bring everything else down. So here's our problem now. We have -11 plus 3 parentheses 14. When we say 3 parentheses 14, that's multiplication. So what we need to do next is 3 times 14, which is 42. So the next thing I'm writing is -11 plus 42. And finally, I can combine those together using my rules for adding and subtracting. -11 plus 42, really what I'm doing is subtracting, because those signs are different. And I'm keeping the sign of the bigger number, which is positive, so our answer is 31. So once we replaced the variables with numbers for this problem, it really became kind of a review of order of operations after that. All right, good. So what comes after this in our PowerPoint that we're looking at is lesson 13. That will get its own video. What I'm going to do right now for the remainder of this video for lesson 12 is I am going to show you some examples from our MyLabs Plus homework. So that's the next thing we'll take a look at. All right, here we are looking at homework number 12. And let's let's go over some of these and get a little more practice with translating expressions and then evaluating expressions. So here's number 1, a number divided by 9. And if we read the directions above, it says, write the phrase as an algebraic expression. Let x represent the unknown number. Okay, so a number divided by 9, that will be x divided by 9. I have a couple options for how to do this. I can type x, and then I can click on this division symbol, and then type 9, that's fine. Another way I could do it is as a fraction, x over 9. Either one of those would be fine. So I'll do the division symbol first. Okay, and I'm just going to click similar question to show you that the fraction will also be fine. So the question just regenerated. Now it says a number divided by 4. Instead of using the division symbol like I did before, now I'll use the fraction button here, sorry, with the 2 blue boxes. So x can be in the numerator, and then 4 in the denominator. So a number divided by 4, I could write it as x over 4 as a fraction. All right, that's number 1. Number 2, 13 more than 6 times some number. The phrase can be translated to, and then there's a blank space to type the answer in. Type an expression using x as the variable. Okay, so let's think about this one. 13 more than 6 times a number. So 6 times a number can be 6x. 13 more than that means I'm going to add 13. So the best answer, I believe, would be 6x plus 13. However, it is okay to switch the order for addition because of the commutative property. So I could also write 13 plus 6x. Either one would be fine. Okay. But number 3, now order will definitely make a difference. So number 3 says 12 less than D. I'm going to type in what I see most students doing the first time around, which is writing 12 minus D. This is going to be wrong. Okay, so let's read our little error message. It says you translated the phrase D less than 12. Remember to subtract 12 from D. Okay, so 12 less than, oh yeah, that means the 12 is actually being subtracted. Okay, so this is an example of the order of our phrase in English does not necessarily match the order of our phrase in algebra. So 12 less than something actually means I'm subtracting 12. What am I subtracting it from? In this case, D. So 12 less than D, I would write D minus 12. Okay. And now I'm going to try to type capital D just to see if it'll let me do that. Oh, it's fine. Okay, sometimes it doesn't like that. So be careful. In general, keep the letters matching, either lowercase or uppercase. In this problem, it still accepted my answer with a capital D, but that's not necessarily always the case. All right, number 4, 5/9 of a number. I would write 5/9 and then X next to it. Number 5, the sum of S and twice T, that would be S plus 2T. That's a similar, we did a similar problem to that in our notes. All right, number 6, -37 multiplied by D. You can write -37 and then click on this little dot for multiplication and then the D, that's fine. Or we could also just type it with the number and the variable right next to each other without the multiplication symbol. So I just regenerated the question, similar question, -46 multiplied by T. I'm just going to write -46T. Here's what you don't want to do. Don't type the letter X on your keyboard for multiplication. That's not okay. It thinks that you're using X as a variable, so don't do that. All right. So again, -46 multiplied by T, we can just write -46T. Okay, number 7, M subtracted from Q. Okay, so the thing I'm subtracting from comes first, that's Q. M subtracted from Q, that means I'm subtracting M. So this is actually Q minus M. So notice the order there. Number 8, 32% of some number. Okay, this one has a slightly different instruction down below, which we often don't bother to read. It says type an expression using y as the variable. So we just got used to using x, and now it's asking us to use y. So just an easy thing to miss there for number 8. So 32%, I'll type 0.32 or 0.32. Now watch, if I just type x, it's not going to accept it because the directions are asking us to use y. So just be careful, read your directions. So it should be 0.32y. All right. Okay, so those are the first 8 problems. There's 15 in this homework assignment. So the first 8 were translating, and now the last 7, I guess, are going to be evaluating expressions. So these are the ones where you're plugging in a variable, or excuse me, you're plugging in a number for a variable. So I'm not going to do all of them. Let's maybe find a hard one. Here's number 10, z over y. For z equals negative 135 and y equals negative 9. So I'm just writing negative 135 over negative 9, and then I just need to divide. 135 divided by 9 is 15. Negative divided by negative is positive. So my answer is just positive 15 for that one. All right. Number 11, we saw one like this in our notes. This is 5 over x plus y. Okay, so an x is 43, y is 2. So I'll write a fraction 5 over, instead of x plus y, I'll write 43 plus 2. And then I'll simplify. 43 plus 2 is 45. Now if I just type my answer in like this, 5 over 45, I'm getting this error message that says, although your answer is equal to the correct answer, it is not in the correct form. You need to reduce. That's what we mean by simplify your answer. Okay, so I need to reduce this by 5. It becomes 1 over 9, because 5 divided by 5 is 1, and then 45 divided by 5 is 9. So 1/9 would be my answer. All right, number 12, 18m over n. All right, so 18, and then m I can replace with 20, so 18 times 20 over, and then n in the denominator I can replace with 5. Now you're using your calculator at this point, so it might not be that big of a deal. You can just multiply 18 times 20, which I'm doing right now, getting 360. So we have 360 over 5, then just divide by 5 and we get 72. So that's one way to work out the answer. Another option, if you're not using a calculator, which you technically don't need to use here, you can actually reduce in a different way. Think of this like 18 over 1 times 20 over 5. 20 over 5 is just 4. So then we can just do 18 times 4. And we still get 72. So just a little reducing you can do ahead of time if you want to. Either way, we get the same answer. Okay, but chances are when you get to that problem, the numerator might be a little bit large, so feel free to reduce. All right, number 13, 6x minus y, when x equals 5 and y equals negative 8. Okay, so some potential for errors with negatives for this one. 6x, I can write that as 6 times 5 because I'm replacing x with 5, and then there's a minus sign, and now I need to replace y with negative 8. Okay, take a look. So it's 6 times 5 minus negative 8. Not just minus 8, it's minus negative 8. So be careful here when we simplify. It's now going to become 6 times 5 is 30. Minus negative 8 actually becomes plus 8. Okay, so it's not 30 minus 8, it's 30 plus 8. So be careful when you're replacing a variable with a negative. Notice how I put parentheses around the negative 8. And I kept the minus sign that was already there. So it's easy to miss one of those. For that one, so be careful. So again, 6x minus y became 6 times 5 minus negative 8, which turns into plus 8. All right, that was number 13. Next is 14, which is a longer one with some exponents involved, and then number 15. Okay, number 15, I will just say, is very similar to one we did in our notes. Ours had n squared. This one has n to the fourth. So just be careful with your exponent. I'm going to go back and let's do number 14. This one's a bit longer. So it's 43 minus r squared plus s divided by r squared, when r is 3 and s is 27. Okay, so for both of these expressions with r, they both are r squared. So maybe I'll just simplify that now, I guess. R squared, that's 3 squared, which is 9. So I'm just going to replace r squared with 9. So 43 minus 9 plus, instead of s, I'm going to write 27, and then divided by, instead of r squared, we did 3 squared, which is 9. So here's the full problem right now. 43 minus 9 plus 27 divided by 9. Okay, remember your order of operations. Don't just go left to right at this point. We evaluated exponents already. Now we can do multiplication or division. So what we need to do next is this 27 divided by 9 at the end. That's 3. So here's where we are. 43 minus 9, and now just plus 3, because we did 27 divided by 9 is 3. Now that all we have left to do is adding and subtracting, now we can go left to right. 43 minus 9, that would be 34. And then 34 plus 3 would be 37. All right, 37 is my answer. Good. I mentioned number 15 is similar to the notes, but I think I still want to at least get you started with this one, mainly because the exponent is different. So it's m plus n parentheses 5 plus n to the fourth, close parentheses. M equals 12 in this problem, and then n is 5. There's 2 different places to plug in n. So let's carefully rewrite this. Instead of m first, I'm going to write 12 plus, then I'll replace n with 5, then parentheses. Inside the parentheses is 5 plus, and then n to the fourth, I will write 5 to the fourth. Okay, 5 to the fourth, it's not 20, okay? It's not 5 times 4, it's 5 times 5 times 5 times 5. So feel free to use your calculator for that. 5 times 5 times 5 times 5, we end up getting 625. Okay, so when I rewrite this, it's 12 plus 5, parentheses, 5 plus 625. So it's going to be a nice big answer. Okay, next we can evaluate in the parentheses. 5 plus 625 is 630. Okay, so keep going. 12 plus 5 parentheses 630. Now the 5 parentheses 630, that's multiplication. So 5 times 630 is 3,150. And now we just finish it by adding it with the 12. So 12 plus 3,150, that's going to be 3,162. So kind of a surprise large answer. That's what we get for having those big exponents in the problem. All right, good. So that was lesson 12. I'm going to end the video here, but please come right back for lesson 13. So on our schedule, we do have lesson 12 and 13 being covered on the same day. So if this was a normal class, we'd be doing both of these lessons in the same class. So both videos are on our schedule for Thursday, July 9th. So make sure you're watching both. All right, thank you very much.